Hi, I'm Susan Nash, and I'm here to talk to you today about decarbonization and sustainability opportunities for geoscientists and engineers. So I'm just going to take a look at the changes that are happening, the opportunities to really contribute to new initiatives in what really is going to result in more electrification, more uses of electricity, and the use of renewables and different sources to essentially eventually go to 100% electrification. At least that's the goal. In the meantime, there are many ways that we can contribute to having a more efficient use of the resources that we do have, and also to eliminate pollution. So let's first start with a definition of decarbonization. A low carbon economy, LCE, low fossil fuel economy, LFFE, or decarbonized economy is an economy based on low carbon power sources that therefore has a minimal output of greenhouse gas, GHG, emissions into the atmosphere, but specifically refers to the greenhouse gas, carbon dioxide. It can also refer to methane. So, with that in mind, the core skills that you will need to become a participant in decarbonization are the following. You'll need fundamentals in geosciences, geology, geophysics, engineering, environmental science fundamentals, renewable energy basics, and data science, neural networks, coding, platforms, environments, applications. So one of the areas we can take a look at is natural gas optimization. So we're talking about the production, exploration for, production, and processing, as well as transportation of natural gas. So decarbonization would involve also cutting emissions, creating value. So let's take a look here at mini and mobile LNG and CNG plants. So instead of flaring, for example, the idea is to liquefy or compress. Also, let's think about local electricity generation, and so we can use natural gas for locally generating electricity, and also putting mobile computing solutions such as blockchain that use a lot of electricity, putting them actually right next to the gas-powered electricity generator. Also, we can look at co-produced products such as helium. Energy minerals, lithium, rare earths, uranium. So basically why? Well, we'll look at battery storage and also return to nuclear. So we can revisit the concept of nuclear power generation, electricity generation, and also kind of micro or mini nuclear plants. You could have one in your basement. Maybe not. Maybe you wouldn't want that, but you never know. The future might be miniature. Let's take a look at carbon capture, utilization, and sequestration. Carbon capture, utilization, and storage is a method of significantly reducing CO2 emissions to the atmosphere. So basically, we capture the carbon dioxide as it is being produced in energy or industrial processes, and we transport the CO2 to an injection site, and we inject it into the subsurface. Then we can store the CO2 and then later use it for stimulating production, in gas fields for enhanced oil recovery, and Also, we can use it for other novel uses of the gas. So we can monitor flow, use it for reservoir modeling. So when we decide where to store the carbon dioxide, it involves quite a bit of work for geoscientists. Okay, another thing that geoscientists can do in the new decarbonizing economy is to detect and reduce emissions and spills. One way to do that is through aerial detection and analysis, drones, etc. And also another way to do it is to eliminate flaring. So you can do that with mobile conditioning and compression or liquefaction plants. One thing that's very important is for the person involved in community solutions is to have a whole earth philosophy. So it's very important to understand geology and environmental science in order to effectively address alternative energy solutions. So one could use this information for siting, for avoiding seismic issues, working with civil engineers, etc. A geoscientist or engineer can use machine learning and analytics for optimization and prediction of maintenance, and also for developing sensor solutions and monitoring, as well as analyzing. Environmental geology is another key component of the decarbonization process. So, for example, let's take a look at water. Water is often produced in conjunction with oil and gas operations, but then there's also water used in conjunction with, say, brines or lithium, rare earths sometimes. So how do we clean? How do we purify? Let's look at green oil field chemicals. Also, we have to understand the geological impacts of climate change. So a geologist will understand sedimentation and also the processes in beach erosion, coral reef tracking, fluvial systems, and there are so many opportunities. You can work with an insurance company, you can work with tourism, festival planning, work with the government. All these things would have to do with understanding the geological impacts of climate change. In other words, the impact on the surface geology, geomorphology. Another big area is detecting, monitoring, and remediating areas of leaks and spills. Another area is hydrogeology, and also working with new technologies, for example, microturbines for streams and communities, localized electricity generation. Also environmentally friendly transmission. Transmission of what? Transmission for your car? No. Transmission of electricity, taking it from one place across the country to another. Also, environmental geology is critical in understanding geotourism opportunities and collaborating with existing travel industry enterprises. So one thing we want to do is take the carbon out of the atmosphere. How? We don't want to take all of it out because that would mean there'd be no photosynthesis. So let's just take a look. So we want to look at planting trees, planting different kinds of bushes, plants, grasses that also generate a lot of oxygen, take CO2 out through photosynthesis. Then also we could look at new geochemical processes that take CO2 out of the air, and also how to eliminate CO2 and CH4, methane. So think about a CO2 sponge of sorts. So here's a way of envisioning new technologies. Let's look at the carbon sponge. We could develop walls and building materials that pull CO2 from the atmosphere. Now, one way that that's being done now is by means of vertical gardens, as in the case of Mexico City, where you have a wall that is basically kind of looks like ivy. It's covering that entire wall, but the plants themselves are a little bit more substantive. They're very beautiful. Also, we could have emission sponges in the median of highways or in the guardrail, in fact. So plant flowers, milkweed, etc. Another thing to do is to minimize waste through completion and production techniques. Think about more efficient fracs, return to vertical wells and low impact, low footprint production, minimize and reduce produced water. So also think about new innovative businesses, repurposing. So what can we do with abandoned or underutilized oil and gas assets? Can we repurpose them for other industries? For warehousing, supply chain, medical, power generation? Also, let's take a look at environmental assessments and rehab. And also let's think about, wind turbine blade reuse, new robotics that process waste in order to create reusable new products. Let's think of electrification via alternative energy. So we can seek hybrid and blended solutions, optimizing with analytics, evaluating pros and cons, and citing locations for the alternative energy. And let's think about using the whole earth concept. So geothermal, wind, solar, microhydro, nuclear, biofuel, those are some of the major ones. Improvement in solar and wind. Electricity from solar power drops in cost by 25 to 30% for every doubling in scale. This is critical. This is one of the reasons for adoption of solar and the widespread use of it. Battery costs drop about 20 to 30% per doubling of scale. Wind power costs drop by 15 to 20% for every doubling. Scaling leads to learning, and learning leads to lower costs. So finally, let's just recap. The goal is electricity. So we need to match skills to the tasks to achieve cleaner and more efficient operations and more sources of electricity. At this point, transmission capacity is insufficient to achieve the goal of 100% electrification of the U.S. in the near term. However, local grids and locally sourced electricity can enable communities to achieve local goals and also avoid energy poverty. So I hope that this has been a nice preliminary introduction and useful for thinking about how exactly to fit one's skills for the future, and also to identify how to develop your own human capital. So, hope you've enjoyed it, and thank you.